Hi everyone, I'm Skywaston and this is fifth part of the Godot FPS tutorial series. And in this video we will implement health for the player and perform three things in this video. The first is that the health we make for the player, we will display it in our heads-up display over here. The second thing is that whenever an enemy shoots the player, the direction of the hit is going to be shown in the form of an arc. So suppose if I'm looking over here and the enemy shoots from this direction, on our screen the arc will show up at the bottom right section of the screen. And the third thing is simply implementing the game over logic. So once the player health depletes to 0, we show a screen and allow player to replay the game. So these three things are what we will implement in this video. So starting off, let's begin by creating the UI for health display. For this I have created this very simple UI for displaying the health and the arc. These two actually are from material icons, and this one is made with basic primitive shapes. So I will download these. I will download these as SVGs, and you can get these assets in the GitHub repository that I have shared in the description. So after these are downloaded, I will going to paste them in the project. So inside of assets folder, I will create a new folder. Let's name this textures, and let's bring it in Godot. So the assets are in here. We will start off with updating the heads-up displays. So let's make some room for the health bar. So we are going to put, first of all I will duplicate this display, and basically the size of the health is going to be similar to the weapon display. Okay, so this is it. Let me rename this one to health, and I will remove the pistol node. Then I'm going to change the type of this node to a texture rect, and then I will set halt outline as the texture. So by default it's going to set health controls side to the texture size. So we can fix that by setting expand mode to ignore size. Then I will set stretch mode to keep aspect centered. So that means whatever the size of this control node with whatever aspect ratio it is, the texture is going to maintain its own aspect ratio. So that's the part of aspect here. So yeah, I think I will perhaps make it a little bit smaller like this. Yeah, this looks good to me. Let's run the game and see how it is looking like. Maybe we can make the hood a little bit smaller. Yeah, looks good to me. So now with the outline done, inside of it I will add another texture rect. I can basically just duplicate it so that I have the default, I have the same values again, and I will rename this to anything, let's say display. And for the texture here I will use the filled texture. So yeah, this is it. And now what we want to do is we want to give an effect that when our health is reducing, we show it like a health bar. So right now it doesn't look like that, and to simulate that effect we are going to make use of a mask. So inside of display texture rect node I will have a color rect node, and this I will rename as fill. So this is going to act as a fill, and I will attach it to the bottom of this parent control node. So I will choose this option, bottom wide. Okay. So now what I will be doing is basically, let me just put it somewhere closer to here. So yeah, what I will be doing is that I will be increasing the fill or decreasing it, and for that I will be representing it through this color rect. And all we have to do now is just mask it so that all of this is displayed inside of this color texture rect node. And for that what we have to do is set the visibility. Inside visibility, set this property which is clip children to clip only. So what it does is, now if I stretch this fill node, we can see that effect we want. And the reason I went with clip only is because if I go with clip plus draw, so the draw part means that this node itself is going to be drawn, and we don't want that. We only want this to act as a mask, so that's why I will set it to clip only. So this part is done, and now we will be coding this fill in the code. So for that let's have a look at the transform of this fill node. And so the idea is that our health is going to be basically something like 100%, 50%, 25%, and what we want is that we want to add that value to one of these components, and it will be easier if there is just one simple component that we can update. But right now if you see, even though I have put it at the bottom, and if I try to increase its size, you can see at the right hand side that both the size and the position, the y components of both of these properties are being updated, and that kind of makes it unnecessarily complicated, right? We want to make it simple. So for that what I will do is I will first of all have some minimum height for this fill object. We can go with anything. I'm going with let's say 8. Okay, so I'm going with a size of 8 for the y component. And then what I will do is I will update the scale instead. So I will uncheck this lock so we can independently update values. So I will use this scale to simulate that fill effect, as here we only have to deal with just one value. So yeah, right now you can see that when I'm going positive, it's going in the bottom direction, and we don't want that. To fix that, we can simply set pivot offset ratio to be at the bottom, especially the y part. So right now you can see it's at the top left, so I can set it to 1, and now it's at the bottom left. The main idea is that the y should be at bottom. Okay, and so now if I increase the scale, this is much more easier for us to understand now, as positive means in the above direction. Okay, so what I will do now is that I will set y component to 0. So that's going to be when our health is completely 0, and maybe we can put it a little bit above, so something like this. Let's say 45. So if our health is 0%, the scale dot y is going to be 0, and if our health is 100%, so we will see at what value we want this to be at 100. So we can say something like 5.25. So this is going to be the 100% of our health. Okay, so with this done, what I will do is now I will just set it to middle over here, and the UI part is done. Now I will implement the health logic. So for that I will create another component, and that is going to be our health manager. Let's set the name of the class to player health manager, and add a node and attach the script to this. And then inside of player I will add a reference to health manager, let's set it over here, and in health manager we will set reference to player. Now I think of it, in the earlier video I said that, I mean, we can do something like just programmatically set reference, and I think it is much easier like we did with enemy. But since for other components we are doing like this, so let's do it this way only for now. Later on we can refactor it, though I doubt I will do this in this video series, but you can definitely do that, similar to how it is done with enemy. Okay, so yeah, this is our reference to the player. I will also add a reference to the fill. Okay, let's call this health fill, and this is our color rect. Let's put it inside UI group, and let's set the references. This is our health fill, and now let's create a function which is update UI. So yeah, this is it. I will also going to define a health variable now, since now we have health for our player similar to the enemy where we had health defined. So in health manager I will have first of all a default health, which I will name as something like default health, and let's have it as 100, and then this is going to be our current health, and this is simply going to be this constant default health. So we will initialize it with default health. Okay, so now what we do is let's first add the logic for update UI. So first of all, let's find out the percentage, and this is simply going to be health divided by our default health. And a thing to note here, that both of these are integers, so if we do the division, it's going to be where we will not get the decimal and only the quotient, and so that's going to be not correct. So that's why we need to have this which is our default health as float. So this will give us a proper float result. Okay, so with this done, we now have the percentage. So suppose if our health was 50, so 50 divided by 100, which is 50 sorry 0.5. Okay, so it's 0.5, and if I have to set the value of fill to 0.5, I mean, we can do that. It's going to be something like at the very bottom. So we need to know what it is going to be its value, which is going to be at the very center. So for that, what we need to know is the maximum value of it, which we earlier find out was looking good around 5.25. So for this, I will set that define a variable for this part. So let's have it right up here. Let's call this health fill max y, something like that. Yeah, this is quite a big name, but it doesn't matter, right? So let's set it to 5.25, and all we have to do is just multiply this percentage with this health fill scale max y. Quite a long name, but anyways, and we set this to our health fills scale dot y. Okay, okay, so it didn't show the autocomplete, so I was a little bit confused. Yeah, so this is it. So that's the code for updating UI. We can check it out. So inside of so yeah, we will not call ready. So since this is a component, we will at start we will the ready code is going to be inside of start, and I will call update UI inside of it, and then in our player I will simply call health managers start function over here. So yeah, now let's run the game and see how the fill is going to be. So for that, I will going to, and yeah, one more thing, I have a habit of manipulating the size from over here, but in this case we don't want to do that. We want to manipulate the scale directly from over here. I mean, we don't want to use these gizmos, right? This will be changing the size and position. We don't want that. We want to directly manipulate the scale, so we can do it while in scale mode or from the inspector. Okay, so yeah, so now the it is set to around 50%, and we will run the game. And before that, yeah, also let me see, yeah, we have the references set. So let's run it and see how it's going to be. Great, so we have it as full, the health bar is filled. So since we are testing only right now, let's try out some more values. Suppose if it's 100, and if for example we had health as 75, so it's going to be 75%. And if it was 50, it's going to be half, and as you can see, it's working. So the code for UI is working. Let me reset it to default health. So with this done, our next task is to implement a function which is take damage, so we can basically register damage that when enemy shoots at us. Okay, so it's going to be very similar to enemies take damage function, perhaps a lot simpler. So I will copy these two arguments in player health manager and paste it over here. And then first of all, I check if our health is less than or equals to 0. We simply return out of this function. Otherwise, we update the health by subtracting amount from it. And also I will define a signal. Maybe I will do it shortly. For now, let's stick with this. And I will also for now add an underscore to the hit pose. We will require it in a while when we add arc to display the direction from where we were shot, but for now we will not use it. And then if our health is equals to 0, and maybe just to be on safer side, let's say less than equals to 0, then we want to do a couple of things. So first of all, what we do is we disable collision. Okay, so we got an error over here which is expected indented block. Okay, so I have actually not written anything. Yeah, so first of all, what we do is we disable a player basically, and that is we will not remove the player from the scene. We will just disable it, and part of the reason we will not remove it because we have a dependency of player in our global singleton, but also it's generally not really required to remove it. We can just disable it. So starting off, we can disable collision, and that's simply going to be player dot collision layer equals to 0, player dot collision mask equals to 0, and this will disable collision for the player. Then we can disable processes. These are basically some of the life cycle methods of a node. So in player we have the input, process, and physics. So these three we want to disable. Okay, so that's going to be set process input to false, set process to false, and set physics process to false. And this is it. This is all we have to do for now. And of course we want to call this function now, which is take damage, and we do so inside of enemy weapon. So earlier we were just printing out attack player, but now we are going to actually attack the player. So it's going to be result dot collider, which is our player. Then we have to get the hit position, and our hit position is, I always forget the name of it. Yeah, it's the intersection point position. So it's going to be result dot position, and finally we do player dot health manager dot take damage, and in amount we can have let me just make it full screen. So for the amount we can have let's go with 10, and for hit position we will pass hit position as the argument. So this is it. Now we will be getting hit by the enemy. I believe we can try it out now. Let's see. So now I will go towards the enemy, and okay, nothing is happening. Let me just check. So let me just see what amount we are getting. So we are getting the amount of 10. That's working. And then we are subtracting health. Let's do that. Okay, one thing I just realized, I think it's working definitely. What I haven't done here is I need to update the UI, which should be done. I'm sorry. So yeah, this part is required. Okay, we have to update the UI, and now let's run the game now. So that's why I wasn't like seeing any change. Okay, we are not again seeing change. Okay, so yeah, I have to get a little closer. And now when the health is 0, we player cannot be moved. Okay, so I mean, of course, it's not possible to show it visually, but I am pressing keys and the player is just not movable. So first of all, let's fix a few things. So right now you will see that if I go towards the enemy, let us make the enemy come towards us, and as we can see, we are not getting hit, and that's simply because in enemy weapon we need to increase the attack range. So let's go with 2. Actually, the reason is also that in the previous video, yeah, it's working now. Great. So I think 2 is great. So yeah, the reason is actually you remember that in previous video um, I had to increase the target desired distance for the nav agent for enemy, so that we don't get that error, and that works. I set it to 2, and that's probably the reason it stops at the distance of 2. And so it's a good idea to have our range, our enemies. Maybe we can just do that only. We don't need attack range. We can instead just go with enemy dot. Do we have a reference to the enemy? Okay, in our enemy weapon we don't have. We can just have a reference to it. Let's call this export var enemy, and then we can say something like nav agent dot target desired distance. That is going to be our range, and perhaps I can set it. I can set it over here. Attack range, so it's at least a little descriptive. So this is going to be our attack range. So yes, let me just put it in over here. So now I think this is much better. And of course I have to set the enemy. So this is a little bit a detour from our actual objective of this video, but yeah, I think it's good to refactor this part. So where was the weapon? Yeah, over here it is. Now we can see it in action. Yeah, I think this is way better. So yeah, our health is depleted now. So now we cannot move or do anything. So I think it's a good idea to show a game over screen. Okay, what is this? Float is converted to integer and loses precision. I'm not sure why I have it as float. Okay, maybe we can make it float only. Why not, right? I'm sorry, I'm doing a lot of changes, but I sometimes it's something we realize along the way. So I think it's much better to just have it as float only, right? So we can actually make things a lot simpler. Yeah, this is much better. I mean, integer is always good for optimization and all, but I think for convenience we can just go with float. I mean, it's not a big deal. So this is it. Now let's implement game over screen. Okay, so for that I will create a new scene, and this is going to be a control node, and let's call this game over. I will save it inside of main, inside a new folder, game over. And then let's add a script to it, and I will call this class game over, or perhaps something like game over menu. Much better, I guess. Game over menu. I will just do a rename, a quick rename. Now I'm a little bit always concerned in Godot when we do a rename and stuff, so I'm just closing that. So we don't get any weird errors, though it doesn't happen in Godot and latest versions of Godot 4. I mean, this used to happen a lot in Godot 3 and even early versions of 4. All that reference errors and stuff. So yeah, this is game over menu set up. Inside of it, let's add a background. I'm just doing something random. You can of course make it much nicer. So it's going to be a dark transparent background, and then I will have a button, and this is going to be a replay button, and let's put it at the center and have font size something large. Yeah, 56 looks good to me. And let's run this scene. Yeah, so right now it's hard to see the background of the button, but in our game it's going to be much easily visible. Okay, so let's put this game over inside of our main scene. Okay, not inside of player. So for that we can create a canvas layer, and inside of this let's have the layer to default 1 for now. We will see if we have to increase it. And this is our game over menu added. Yeah, so let's run the game and see how it looks. Yeah, so this is how the screen is going to look like. I mean, the cursor is already at center, but yeah, it's okay. So first of all, in here at ready, we are going to hide it by default. Okay, and then I will have a reference to our replay button. Let's go back to the scene and let's set it to replay button. Then let's add a signal. I mean, let's connect buttons press signal to a function. Let's call this something like on replay button pressed, and we will do something over here shortly. And before that, let's define a signal, our own signal inside of global, and this is going to be game over signal, and we will emit it in, like, first of all we will define a function within this script only, emit game over, and we will emit game over signal from inside of here. And now all we have to do is just call this method. And part of the reason is that we usually get a warning if we call this from somewhere outside. So that's why I have wrapped it inside of this method, and of course there's definitely a design choice for that. And I think it's much easier, I believe, to just do a search of it wherever it's being called. I really hope that GDScript have that feature, like in other languages like C sharp, or like a TypeScript or anything. We control click and we can see all the references, right? If that is added, that's going to be really helpful. But anyways, yeah, this is it. We have defined this method. Now what I have to do is that in our player health manager, when our health is depleted to 0, it's here we will declare that the game is over, and we will just emit global dot emit game over, right? So a couple of things are going to happen. So the very first thing is, of course, that we will show this menu. So I will have global dot game over connect, and let's connect it to a method. Let's call this on game over. And inside of it, let's keep things simple, and I think all we have to do is just enable it. We can see it, how it looks like. And let me just see if I have added the reference or not. Yeah, it is set. So now our health is being reduced, and yeah, we can see the screen. And one thing we have to do, one more thing, and that is I will set the mouse mode to visible. So as you know that in our code base we had earlier set it to captured in player, because when we are moving the FPS controller, like just looking around the screen, we don't want mouse to be visible and just go around the screen. That is a very bad user experience, and just doesn't work. So that's why we captured it, confined it at the center, and just made it invisible. But now when the game is over, we want to show the mouse. So let's see it now. Maybe I will decrease the player's health so we can quickly see the result. Yeah, so this is working. So now I will just do one quick update, and that is I will reduce player's health to something like 50. Okay, and back to game over menu. Inside of here I will just reload the scene. For now we will keep things simple. Okay, and yeah, I think this is all we have to do. I don't think we need to capture it because we are reloading it, and the players ready will already call it. So I think we are good to go with just this much. Let's see how it works. So the game is over, and now if I click replay, yeah, the mouse cursor is again confined to the center, and this is it. Just one more thing, you can see that enemy is still attacking us, and we can quickly fix it. And to fix it, all we have to do is go to enemy, and inside of ready we can connect global's game over signal to our custom method, which is on game over. And on game over, all we have to do is just set our enemy's state to look, and that is it. And since we have disabled player collision, we don't have to worry about enemy look like detecting our player again. It's not like it's going to happen because we anyways disable collision. So yeah, so nothing, not much of a big deal. So yeah, so all of it is all set, and now if we run the game, we can see the enemy is no longer attacking us. So I think this looks good to me. We are done with the game over menu. So we have completed two things, which is implementing health and showing it over here. And when the health is depleted, we show the game over screen. So now the final thing is to show that arc, okay, when we get hit by the enemy. Okay, so for that, I will create a new scene, and this is again going to be a control node, and I will name it arc hit. I'm not sure what's the right term for this thing, but I will just call it arc hit. And I will actually place it inside of player and save it. So the way it's going to work is that this is the parent, okay, arc hit, and this should be at the center. But most importantly, I will have the size of this control to be at 0. It's a vector 2 of 0 0. Okay, and let's put it at center. And now inside of it, I will add a texture rect, and let's call this arc. And in assets, I will put this texture inside of this field, and I will set it to ignore size and keep aspect centered. Let's increase its size a little bit. I think this looks fine to me. Yes, and let me just again put it at the center. And now all I will do is move it up a little bit. So yeah, this is it. And with this done, what I will be doing is basically rotating this arc hit, and that is going to tell us the direction from where we have been shot. So now I will create a very simple animation just to highlight that we have been hit. Of course, this can be used for like something like a stealth meter, stealth arc, like we see in Far Cry games and many other games. So the very first animation is going to be hidden animation, and this is going to be the default. And I will in here just going to first of all, let's anyways have a keyframe for the scale, and the second keyframe is going to be for modulate. Let's go with self modulate. I mean, we can go with either of these, but let's go with this, and it's going to have an alpha of 0. And yes, this is it. This is our default hidden animation. And with this done, the second animation is going to be the show animation, and I will set its nearest FPS to 1.1 and enable snapping. This just makes the navigation easier in animation player. So first of all, I will again keyframe the scale and self modulate. Let me just see what's the reset. Yeah, so this is correct. Okay, so this is our starting frame, and then at 0.1 second, I will going to make it opaque and have a color of red. And actually, let's have the very first frame as red too. We don't want to have it as white transparent, right? So yeah, this is the modulation part, and then I will just manipulate the scale a little bit. So let's go with something like, and one more thing, I will set its pivot offset. So right now it's at the top left. So that means if I scale it, it's going to scale from top left. To fix it, we will for our animation we want it to be middle. So I have set the pivot offset to 0.5 and 0.5, right? So now if I scale it, it's going to scale from the center. So now our scale at 0.1 is going to be 1.2, and then at 0.2 seconds it's going to be 0.9. I mean, maybe let's go with 0.8, because if it's 1.2, yeah, I mean, we will see how it's going to be like. And then finally we will maybe let's have it to 1.1 then. Let's yeah, I think this is fine. And then at 0.4 we will reset it to the default scale of 1. Let's see how it looks like. Yeah, looks good to me. And then I will make it visible for a few seconds, and more like 1 second only, but the overall length is going to be 1.5. So I will duplicate this till 1 second, and then at the last frame, which is at 1.5, I will make it transparent. So this is how the animation is going to be. I will select all of it, right click at easing and set it to ease in and out. So this is going to have a nice effect where the starting and the ending of each keyframe is going to be a little bit slowed down. So this is what we are going to see when we are hit by an enemy. So this is done. With this done, what I now need to do is I will create another user interface, I mean the control node, and this is going to be our arc hit manager, and I will save it again inside of player. So the idea is that whenever we are hit, we are going to instantiate an instance of arc hit, okay? And let's say in a matter of 2 seconds we got hit 4 times, so we will have 4 of these instantiated, and they can be from all 3 different directions, something like this. And of course we want this to be removed after the show animation is completed. So first of all let's define arc hit. Okay, we haven't done that yet. So the very first thing is going to be a reference to animation player node. And then inside of ready, because as soon as we instantiate it, we will just launch the show animation. Now maybe it would have been a good idea to just have this animation itself, but I have just added hidden as a fallback. So like when I was initially building this project, I had a bunch of different ideas. That's why I had it. I guess we don't really need hidden, but let it be there anyways. So what we will do is we will play the show animation first and foremost, and once that animation is finished, we are going to check for animation finished signal, and inside of it we will simply just queue free, basically remove this node from the tree. Okay, so if our animation name equals to show, we remove this node from the tree. So this is as simple as that. Now I will quickly just go through the logic of So this is the main logic. Okay, so here what we want to do is rotate the arc, the this whole arc hit node, such that from wherever we have been shot at, it is going to be pointing in that direction in 2D. Okay, so to do that, what I will do first is that I will go to player health manager and define a signal which is player hit, and it's over here that I will finally make use of hit pose, and it's going to be our player hit dot emit. And so far we haven't been like adding signature to this signals. I think we haven't done it in other signals as well, so let's keep it like this only for now. No need to have things inconsistent. So yeah, in player.hit, in player hit we will emit our hit pose. So that's all we have to do in here. So we now need to listen to this signal. Okay, and we will do that in actually arc hit manager. So in arc hit itself we already are going to have a variable which is local, its hit position, and this is going to be set by arc hit manager, and we will do that shortly. But for now let's finish this script. Okay, so in process we will get a reference to the player from global.player. Then what we let's see first of all how this is going to work. Okay, so let's see how we are going to rotate that arc hit. Okay, so suppose this is our player and we are looking over here, so we will get the player's forward direction. So that's the first thing, so let's do that first. So this is going to be player dot so like it's rotating, like we don't have to go with the camera itself. We can, let's go with camera anyways just to be consistent. So it's going to be global transform dot basis dot z. Maybe a much simpler one is global basis dot z. Yeah, this is much better, much simpler. I always forget that we have a value for a variable for just this thing. So we will directly use global basis, and we will get the players forward, right? And then I want to get the direction. So suppose we got hit somewhere over here, we will basically get the direction of our player, which is like it's going to be at the center, and the direction to the hit position. So it can be like anywhere around the surface of the player. So for that it's going to be let's call it let's first have the statement defined. So it's going to be player dot global position dot direction to our hit position. So we can say something like you know player direction to hit position, something like this. This is going to be a unit vector because we are getting the direction, right? So now we need to, so now if you look at our 3D scene, suppose we got hit somewhere over here. So that's the hit position, and the direction is going to be something like this. The arrow is going to be pointing something like that, and we want to first of all make it in 2D, entirely 2D. So I will be removing the y component from it, from both of these vectors. So by the way, this is also a direction vector, a unit vector, right? So so these are already direction vectors. We just have to set their y to 0, and I will set this one's y to 0 as well. So now it's going to be completely on the ground, on flat, and these are unit vectors. So since now these are on 2D plane, we can, what we will do now is we will find the angle. So player is looking at forward over here, and we have got the direction of our hit. So we just want to find the angle between these two vectors. That's it. So let's do that. So the way it's going to be is that it's going to be player direction to hit position, and it's going to be signed angle to. So here the order matters, and to be honest, like I just tried out with first player forward first, and then player direction to hit post first, and this one worked. So yeah, I don't know the specifics too much, the math behind it, but I do know that, you know, like yeah, we have to do a little bit of experiment. So I do it like this. I'm sure, like, if you want to know, you should definitely see how rotations work. I have just, you know, like, just tried both of these different orders. Anyways, so this is going to be player direction to hit position angle, and the player forward, and the axis is going to be around the vertical up, which is 0 1 0, where y is 1. So this is how we get the rotation that we want, and we will simply set rotation equals to this float value. So this is going to be a angle, a single float variable, which is going to be in radians, since we are working in 2D for the arc hit. It's a control node, a node 2D node, right? So that is it. That's the process method done, and I mean the whole arc hit has been completed. Now let's go over to our arc hit manager, create a script, and give it a name. So it's going to be arc hit manager, and then add references, and it's going to be, first one is going to be arc hit, and I think that's the only reference we need. And then inside of ready, so first of all, let's add our arc hit inside of our player scene. So I will put it inside of the hood node. So over here it is. I will just do one thing, and that is in our arc hit manager, I will set its filter to ignore, because we don't want it to be blocking any kind of input, just to be on safe side. And I will do the same over here. I will set it to ignore, and same over here, even though we can just have it as pass, but I will just explicitly set it to ignore. Okay, so this is done. And now I will also add a reference to player. So we need a reference to player as well, and let's rename this to arc hit scene. That's the correct, much better name. So back in player, I will set player over here and set arc hit scene like this. So this is done, and now it's going to be player dot health manager dot player hit connect, and we will say on player hit, and in this signal, as we know, we passed this argument. So let's have the signature defined like this, and we have the hit position. And now all we have to do is just instantiate our kit, and this is going to be our kit in scene instantiate, and then we will just add it as a child of our current node. And before adding child, we will set hit position to the hit position, and that is it. Yeah, so this is done. I guess we are all good to go. Let's run the game and let's see. Okay, I haven't set the reference. Okay, I thought I had. Okay, I haven't. So yeah, I have set it, and now yeah, so we can see that we are seeing this. Maybe it's like you saw, right? The enemy's attack range was still too small. I will just very quickly just hard code something. So this is our target distance. Let's make it 1, right? I mean, we can make it something infinite too, but yeah, just let's make it 2. So we don't want that, at least right now. I mean, you can definitely refactor it, but for now I have just went with 2 and hard coded the value. Anyways, so let's see. So we can see the arc hit is working, and yeah, this is it. And just to test it out, I will add a lot more enemies into the game. So again, I will go to the enemy node, and just for testing purpose, I will set detection areas top level to on, so that it stays right there. And then I will just duplicate enemy, so we can see how the arc hits are going to work. And in our player, it's player health manager, let's increase the health to something large so we don't lose the game. And now let's see. So all of the enemies are heading towards us, and yeah, we can see that the arc hit is showing in the direction of the hit. So for example, if I'm here, yeah, you can see that. So there are a lot of enemies, and let's shoot all of them. So yeah, this is it. And also let's confirm that all of the arc hit nodes are being removed from the scene. Yeah, it's empty, but we can rerun the game and see they are being removed or not. So yeah, we can see the arc hits being instantiated in the tree. And let me just, yeah, you can see that it's being removed after the animation is finished. So yeah, this is it. So this part of the video is done, and in the next part we will going to add a win condition for this level and complete the main gameplay flow. So that will be the topic of next video, and after that we will be basically adding 3D models to the game and audio. So in terms of functionality, next video is going to be the final video, and after that there will be 1 or 2 videos where I will finish adding 3D models and audio to the game. So yeah, that is it, and I will see you in the next video. Bye.